Hello, technical knowledge seekers. Hope you're doing well. And as always, if you're new to my channel, I would humbly request you to subscribe to my channel so that you shall be able to watch all my engineering videos that I will upload on my channel. I thank you all. Okay, so today we are going to discuss a very new topic, and that is basically thick walled pressure vessels. Okay, and in the thick walled pressure vessels, we have already discussed the stresses that are being generated in our pressure vessel. That is, whenever it is pressurized, we have the longitudinal axial stress being generated, we have the hoop stress being generated, and we have the radial stresses being generated. But once these stresses which are being generated in a pressure vessel, it will result in strains and elongation of the pressure vessel. And we will be also, while performing the stress calculations, we should also be interested in what are the strains that are being generated and what is the elongation that is being generated for our thick walled pressure vessel. So for that scenario, we have used the following equations to calculate the approximate elongations and strains developed in our thick walled pressure vessel when it is subjected to axial, hoop, and radial stresses. These equations can be used to calculate deformations in a wide variety of design situations for thick walled pressure vessels and for hydraulic cylinders and for the designing of the submersibles. We can use these calculations to approximately calculate the resulting strains and elongations developed in our pressure vessel. Okay, so let us see that whenever, because of uh, the tangential strain that is being developed in our pressure vessel. Remember that these tangential strains are basically being generated consequently as a result of the circumferential or hoop stress and the radial stress. Okay, so for that, the tangential strain developed will be sigma t minus the Poisson's ratio into sigma r divided by as a whole e. Okay, remember sigma t is the tangential or the hoop stress. This nu is basically the Poisson's ratio, whose value is always for steel is taken as 0.27, or some sort of a alloy steel will have a slightly different value. And sigma r is basically the radial stress, and E is the modulus of elasticity. If we are using English units, it will be 30 E6 psi, and if we are using SI units, we can take it as 200 gigapascal. Okay, so you must remember these things, very common, so that while performing numerical, we do not commit any calculation errors. The elongations or the radial displacements in the pressure vessel could be calculated from this equation, which is again sigma t minus the Poisson's ratio into the sigma r, which is the radial stress, divided by the modulus of elasticity, and for the maximum radial displacements we have to multiply with r naught, which is the outside radius. If we are interested in calculating the axial strains developed in the pressure vessel, we will be using uh, epsilon A equals to the axial stress, which is the longitudinal stress, minus the Poisson's ratio into the radial stress plus the tangential stress, and then the whole expression is divided by the modulus of elasticity. So these are the equations can help us calculate the elongations and the displacements and strains developed in our pressure vessel as a result, which are being generated as a result of these longitudinal, radial, and circumferential stresses. I hope this will assist you in designing of a pressure vessel when you are doing it in your job, in your industry, and it would clear your concept. I thank you all for giving your time in watching this video, and regards from my side. Bye.